Hello, my name is Yiğit. I'm the team leader of Guru number 4. Our project is multi-purpose adjustable power supply for the medical devices. Firstly, I want to talk about distribution of tests in our project. I'm Yiğit Yılmaz, team leader. Mehmet Dağ was the system integration engineer. Deniz Onur Akkoç was test engineer. And my friend Feyzullah Apaydın worked as a hardware design engineer in this project. First, I'm gonna talk. Sorry, I gotta talk about problem statement. What was our main problems? Which problems are we gonna fix? Before starting the project, we focus on these studies, these thoughts, these thinkings. Firstly, clean and stable power for the medical devices. They need an extremely clean and stable input powers and accurate voltage and current values from outside, and we gotta see the accurate values. Existing lab power supplies may be expensive or not tailored for medical users, and of course about it for devices, some medical devices may be some expensive. That's why expense price is another important topic for this projects, for this kind of projects. This identification, low cost adjustable DC power supply for medical applications. We focus on low cost, stable outputlarımız, low ripple'larımız, and accurate control and simple control by user. Building safety both user and device, compatibility with the common user medical voltage levels like 5 volt and 12 volts. System requirements, adjustable large voltage output range between 0 and 30 volts, high current limit up to 5 amperes, adjust additional constant outputs like 5 volts and 12 volts, protection circuits, real-time and voltage current monitoring, heat management and for the safety, reset button for recovery system, and compliance with international electrical compliance, international standards 60601 and ISO 14971. Proposal concept, we have four main proposals for this project: simplicity, safety, affordability, and the compatibility. Because we are gonna make a power supply for medical devices. This is the four main terms for this project. Detailed design overview. We have output voltage. We can adjust this between 0 and 30 volt DC. We can supply up to 5 amperes to the medical devices. Additional, we have 5 volts and 12 volts. These are very commonly values used in this area. We can control the adjustable output via potentiometer in a simple way. We have some and commonly used in this project's electrical components: linear voltage regulator, transistor, electrode capacitors, diodes, LED diodes, and cooling. For the cooling, heatsink and fan. LED diodes, for instance, LED diodes shows system is working without problem. My presentation was still here. Thanks for listening me.
Hello everyone, I'm Mehmet Dağ. Now I will talk about implementation and working principle of power supply system. Planning and testing circuit flow. I defined and implemented the entire system flow from input voltage check to output delivery, including AC to DC conversion, regulation, safety checks, and ensured seamless integration between stages. Also, hardware assembly and securing components. I ensured physical safety and stability by assembling components properly using terminal blocks for input-output connections and securing parts with screws or hot glue when necessary. I performed reliable soldering for permanent connections and resolved cold soldering issues. Based on real-time monitoring data, I made necessary adjustments and optimized the system loop. I labeled cables and output ends to avoid confusion and organized the wiring for easy troubleshooting. I analyzed discrepancies between digital voltmeter and multimeter readings and worked to reduce voltage ripple at the output. I also fine-tuned output voltage using the potentiometer and managed overheating issues with the LM317 voltage regulator. I checked transistor connections to ensure the proper operation of the protection circuit. Thank you very much.
My name is Deniz Onur Akkoç from Electrical and Electronics Engineering Department. I'm a test engineer in this project. Now I will talk about the tests we did in the project. Unit tests. We did transformer test for reduced grid voltage to 20 ACRMS using a transformer, and result is pass. We did bridge diode rectifier test for conversion of AC to DC, capacitor test, filtering test, reducing ripple, and these are pass. Voltage regulator test, stable 5 volt, 12 volt, adjustable 0 to 30 volt DC range, current test 0 to 5, digital volt and ampere ammeter test, projecting circuit test for reacting to overvoltage current, and these results are pass. We also did power module, safety module, display module, and result are pass. Load test, thermal test, user adjustment test, safety compliance test, and durability test, and the results are pass. And as we said, adjustable power output 0 to 30 volt and 0 to 5 current, and these results are pass. Production features, user interface, and long-term operation, and results are again pass. You can see the results: 5 volt AC, 5 volt DC here, and 12 volt, 0 to 30 adjustable, 15 volt here, and ampere, as you can see. Thank you for listening.
Hello, my name is Feyzullah Aydın. I'll briefly present the cost, commercialization, and safety aspects of our multi-purpose adjustable power supply. The total production cost is about 2,200 Turkish liras, including the regulators, capacitors, transistors, a heatsink, a metal case, output jacks, and etc. Our development cost is nearly zero because we used open source tools and university support. Marketing will be done through social media and electronic communities with minimal expense also. We plan to sell this price at 3,200 Turkish liras, while similar single output products cost around 3,500 Turkish liras. We offer more value with adjustable and fixed outputs at a better price. We plan scalable manufacturing and sales through online platforms and universities. Distribution will be handled via electronic suppliers and e-commerce. Our design meets the standards, safety and compliance standards written here. The product supports domestic innovation, offers an affordable lab power source, and helps students and researchers avoid high import costs. Thank you for your listening.